Water is absorbed in the large intestine and is lost in the skin and respiratory tract via evaporation. Here it would be via breathing. It can also be lost as urine. The four processes involving water are the optimal state, which is euhydration, the state of losing water, dehydration, the state of having an excess of water in the body. Remember that hyper means too much, and the underhydration, which is hypo, which means too little. Then we have the different ways to measure the electrolyte balance. So there's the color of urine. When your urine is more yellow, let's say, you are less hydrated than when it's more transparent. Then there's the fancy methods, which is an osmometer that measures osmolarity. You don't necessarily need to know what this means. Also have in mind that fat-free tissue, for example muscle, has higher water content, and this means that those with higher body fats have less of a water percentage. Lastly, we have the different functions of water. So there's the transport of nutrients / the removal of waste, as it can be shown by urine. Then there's the evaporation of sweat, which reduces body temperature, the lubrication of joints, and have in mind also that water can be a good place for chemical reactions to happen. Cardiovascular drift involves the loss of electrolytes and water from intracellular fluids via evaporation. So this is an example of how water can move from intracellular fluid, so your blood for example, and extracellular fluid, which would be the sweat. This happens in prolonged steady state submaximal exercise, such as running or long distance swimming, and especially will happen in hot or thermoneutral, so not hot or cold conditions. Another problem in cardiovascular drift is that during exercise your body wants to maintain a high cardiac output, but what happens is that stroke volume starts decreasing over time. So in order to compensate, your body increases your heart rate, and this is because the formula for cardiac output needs both a high heart rate and a high stroke volume, but because the stroke volume goes down, you want to compensate with the heart rate. Hope that makes sense. Because your body wants to maintain a state of euhydration, these two conditions will be detected by the hypothalamus that will activate or deactivate thirst depending on such. So if it is hypohydration, it will activate thirst because it is going to see that you need water, so you need to be thirsty in order to drink water and compensate. In hyperhydration, it will also stimulate the pituitary gland that will secrete more ADH, and this is going to cause a decrease in urine production and a gain and retain of water in the kidneys. And lastly, if it's hypohydration, the pituitary gland will be asked to secrete less of this hormone to prevent the following processes. Having too much sodium, hyper, or too little sodium, hypo, involves the following symptoms: bloating, nausea, vomiting, and more serious symptoms, seizures, coma, and even death. Hypernatremia involves the plasma sodium concentration being too high compared to water, and this is considered anything above 145 millimoles per liter. So this is caused by dehydration, so less water, and high sodium intake, so there's more sodium compared to water. It's frequent in swimming and long distance running, and more common in females and hotter conditions. Hyponatremia is happening more frequently in swimming and long distance running as well, and is also more common in females in hotter conditions. So it is hard to tell which one is going on during these situations, but what we can tell is that plasma sodium concentration levels are too low compared to water in hyponatremia, and this is considered anything lower than 135 millimoles per liter, and it is caused by hydrating too much, so hyperhydration, and a low sodium intake.